Taking a look at worksheet 14, question number 5, we have to decide whether or not the atoms or ions that we're given, if they have unpaired electrons in the ground state. So let's say that we have our example, copper plus, right? So first, how I would approach this problem is you should figure out what the ground state for the neutral species should be. So copper is one of those more interesting cases. So it's one of those exception cases where your s orbital isn't completely filled. Instead, the extra electron goes into the d orbital. So for our neutral species for copper, we have argon in brackets, and it's 4s1 and 3d10. So knowing that's our neutral species, we take a look at our electron configuration for when it's charged, so when it's Cu+. So when it's Cu+, it means it's losing an electron, so we have to take a look at where electrons are most easily ionizable and remove an electron from that orbital. And that orbital should be the highest energy orbital, and in our case, it's the 4s. So we get our electron configuration to be 4s0 and 3d10. And from that, we can conclude that we have 10 valence electrons. And because all these valence electrons are in the d orbitals, and there are 5 unique d orbitals, we can arrange these electrons in different ways. And we're going to find out that all of the orbitals are going to be completely filled with 2 electrons per orbital. So if that's the case, then we don't have any unpaired electrons. And a good reminder for the rest of these problems is that for an s orbital, there's only 1 unique orbital and 2 electrons can fill that. For a p orbital, there are 3 unique p orbitals and 6 electrons can fill those. And finally, for d orbitals, there are 5 unique d orbitals and 10 electrons can fill that. So going through another example, and taking a look at a periodic table, let's figure out if scandium 2+, if it has or doesn't have unpaired electrons. So for scandium, again, we look at the neutral species, and for this, it's argon 4s2, 3d1. Just taking a look at scandium, it's here on the periodic table where my mouse is hovering over. So if it's scandium 2+, that means I'm losing 2 electrons. So again, the highest energy orbital would be the 4s, so that's where it's most easily ionizable. So we remove 2 electrons from there, and we get 4s0 and 3d1, and we have 1 valence electron. And because that valence electron is in the d orbital, there's only one way of putting that electron in the 5 different orbitals. So as you can tell from here, then scandium 2+ does have an unpaired electron. All right, looking at another example, if you have argon plus, well, argon plus is a noble gas, so its electron configuration is argon in brackets. And if it's plus, that means it's losing 1 electron from its very stable shell. And we go up to the next noble gas, which is neon, and we start filling from the lowest energy orbitals, which from here we're looking at the 3rd period, so 2 electrons in the s orbitals, and if you're losing 1 electron, then you're only filling 5 electrons into the p orbitals here. So in total, you have 7 valence electrons. And if that's the case, then 2 electrons are in the s orbitals and 5 electrons are in the p orbitals, we can arrange them like so. So 2 electrons in the s orbitals and 5 electrons in the p orbitals, and you can see that there is 1 lonely unpaired electron here. So that means that there are unpaired electrons in this ion. And just a quick note I haven't mentioned before, that we lose electrons from the highest energy state, which in this case is the p orbital, because it's higher in energy than the s orbital. Finally, our last example, we have iron 3+. If we have iron 3 plus, our neutral state electron configuration is so: argon 4s2 and 3d6. As you can see here, periodic table, this is where iron is. And if I'm losing 3 electrons, I'm losing it again from the s orbitals first because they are higher in energy, and then 1 from the d electron, 1 from the d orbital. So in total, I have 5 valence electrons. And how I place them is like this, because according to Hund's rule, we want to maximize like unpairedness. And if this is the case, then we have unpaired electrons.